So I would like to say thank you all again for joining in. Hi Abdul, hi Kapil, Rajan, Sushant, Yogesh. So,
Hi.
okay. So maybe we can start. Before starting it, I just wanted to know from you guys, are you guys working on SD-WAN or you just wanted to acquire the knowledge for the SD-WAN currently? Or if someone is working on the SD-WAN and wanted to enhance their knowledge? Okay, so I'm considering everyone is new over here. That's all right. So let us start with our today's demo, that is SD-WAN. And Cisco SD-WAN is nothing but it is Viptela. Now, what is Viptela is, what is Cisco, how Cisco got merged from the Viptela. Everything I would try to cover all of those things into today's demo, don't worry. And before that, I would just like to tell you that how this SD-WAN, came into the market. Before SD-WAN, there was a lot of things which were running in the market before SD-WAN as well. Okay, and we people are very much aware about that. But currently, in today's scenario, if we will talk about, all of those things are the legacy one. Now things are getting changed. Everything is gonna go in the virtualization. Not only virtualization, but there is a lot of things. Okay, SDN mainly, which is in the hype in the market. We used to listen this word SDN. So what is SDN? What is SD-WAN? What before the SD-WAN was? How SD-WAN come into the picture? We will be going to talk about all of these things into today's demo. Okay, so before starting it, myself is Radhe Verma. I have 15 plus years of experience in the network industry, and I would be your instructor for end-to-end this course. And let us start. Okay. So if you see here, Viptela SD-WAN is the solution on which we will be working together. And Viptela is nothing but Viptela is was an organization which Cisco acquired before a long time, probably now approx 4 to 5 years. So today I would be showing you a little bit about the lab setup. I would be telling you about what is control plane, data plane, maybe a little bit vManage dashboard I would try to give you, and we'll try to give you some of the basic about the templates, what are those, what are not. Maybe all of these things comes under the SD-WAN architecture. But before the SD-WAN architecture, as I told you, how SD-WAN appears in the market, it is not one, it's not about nightmare that, okay, within a single day, everything is got changed. No, it was came in the market gradually, and we will be gonna check like before that, what was there. So to divide all of these things into a proper structure, I would say there was 3 things. Okay, and in the very beginning, it was WAN 1.0. So WAN 1.0, when I am talking about the things that, okay, in the market, when I am talking about WAN 1.0, I'm just talking about, okay, when I have the things like VRF, when I have all the things like IPsec, when I have all the things like DMVPN, I have MPLS. Okay, so all of these terminology was there in the market, and still it's running. I will not deny that it's not working now. It was there earlier. It is still working perfectly, but yes, all of these things are coming into the WAN 1.0. So let us see what is WAN 1.0 through our one of the topology maybe. Okay, so let us say I need to design a topology. Okay, this is my topology which I need to design, and I need to make all of the sites up. So into this diagram, let us consider that we have 2 of the data centers. Okay, this is my DC1, this is my DC2. There are a couple of the remote location, maybe site 1, site 2, site 3. Okay, and in this site architecture, if you will see, we have 2 kind of links. One link is through the MPLS, one link is through the internet. So this design is as such that maybe site 1 is only connected with the MPLS. Site 2 has only WAN edge devices, and this WAN edge has the dual connectivity from the MPLS and internet. Probably site 3 has the dual connectivity again, but this time we have the redundancy with respect to the hardware also. So we have on the site, we have two routers which are dedicatedly for the maybe internet line and for the MPLS line separately. Then again, of course, DC will be having the dual connectivity and dual routers, dual home. That is much expected. Now, if we will see, if we have such kind of scenario, how the traffic will flow or how our traffic will go from one place to the another place. So normally in such kind of scenarios, we have the BGP and MPLS which will come into the picture. Here, if you will see that we need to create BGP on these links. Whenever we have MPLS, we need to create the BGP. So from here to here, here to here, everywhere where we have the MPLS into my picture, we will be running BGP. Then not only that, when I am running the BGP, I need to send all of my this maybe data center servers links or whatever my LANs are. All of these LANs need to be sent or need to be redistributed into the BGP table. So all of my links will be redistributed into the BGP table. That is one thing. Second thing, when these links are coming to the BGP, your ISP is able to understand that what kind of traffic you are sending. All of the traffic is listened by your ISP. So by that way, your ISP is controlling user traffic. Control is in the hand of ISP. And if ISP don't support one thing, let us say if ISP say that, okay, I don't support QoS, then you cannot apply the QoS on this particular this particular topology. Then you need to be having maybe change your ISP, okay, and changing the ISP again a very pain area. In case of MPLS, those people who are aware, who are sitting over here, that if we need to provision a new site on the MPLS, it usually takes maybe more than 30 days or more than that even. So that was the one thing in WAN 1.0 that how it was implemented and how it was emerged in the market. Second thing, everything is in the hand of ISP. ISP is controlling our, let us say, the routing, our QoS, our multicast traffic, our traffic engineering, any part you say, we were too dependent on the ISP only. Whereas if we talk about the internet, to achieve the security, we can run up the maybe probably we could run the GRE, but GRE is not the encrypted one, we are aware. So we can run with the IPsec, or maybe we can go with the Flex VPN, or maybe some sort of VPN we need to run over here. In this way, we are using the overlaid terminology earlier also. What does overlay means? Overlay is nothing. Overlay means that we are bypassing. Let me just give you an overview by having the three routers. We have router 1. It has connected with an ISP, okay, and there is router 2. So this router 1 is connected with ISP. Router 2 is also connected with ISP. Here, this is my plain maybe internet link. You can consider it. There is the LAN. There is the LAN. When you are creating IPsec, you are creating a tunnel. You are creating a tunnel from your ISP network, which is used as underlay. This will be the underlay technique. And you are creating a tunnel above that. So I hope you guys are aware that there are two phases, ISA-KMP. Okay, that is phase 1. In the phase 1, you have the another tunnel. Those are your ISP tunnels for the in and out respectively. Okay, and this is phase 2. Doesn't matter either it is IKE V1 or IKE V2. When you have such kind of setup, your network will be moving through the ISP from one place to the another place. But at that point of time, ISP not aware about any customer LAN. That is VPN. And these VPNs we were using earlier, even by not when we don't have, SD-WAN. And these were the things like DMVPN, like Flex Connect, okay, Flex VPN, IPsec. These were the terminologies we were using it. For this, internet speed should be better, okay. And yes, internet is much lesser than the cost when we treat with respect to the MPLS. That was our one of the benefit. So this was our WAN 1.0. I hope everyone is aware about WAN 1.0 now. Let us move. Time changed and Cisco presented something else, which is known as maybe WAN 2.0. Now, what is this 2.0? Let us talk about 2.0. Same topology I am treating, and there is some concept which is bringing into the market, and Cisco used to tell it as IWAN, Cisco IWAN, or we can say intelligent WAN. In the intelligent WAN, Cisco come up that, okay, why to give the control to the ISP? It should not be have the control with the ISP. It should be have the controls with respect to the user only. User should be the one who is controlling everything. And for the same, they have done couple of the changes with respect to your configuration, with respect to your terminology, so that everything can be fantastically fine. The very first thing which they come up with the transport independence. Transport independence. So it doesn't care that either it is a MPLS, either it is a internet, either it is LTE, either it is maybe 5G, 4G, whatever the transport you are using, it does not care about that. How they achieve this kind of task is, so towards the ISP. So let me say that this is the ISP which is going towards the MPLS. This is the particular link which is going towards the internet. Towards the ISP, we are running a separate VRF. And this VRF will be known as front door VRF. VRF, all of we are aware that when we are using VRF, it means we are using VPN v4. And if maybe someone is not aware, let me just tell very quickly that what is VRF is. So in case of MPLS, you guys have heard about this term VRF. So if we have customer A, we have customer B, and we are using the VRF onto this side, like VRF A, okay, and this side we are using VRF B, and whatever traffic which is coming over here and coming over here, it is getting into the container named as A and B. These are the VRF. So let us say this is using 10.10.10.0 slash maybe 24 subnet, and this customer is also using 10.10.10.0 slash 24 subnet. If there would not be any concept of the VRF, router will not able to recognize that which subnet belongs to which customer. But since there is the role of VRF, let us say we have the RD value over here 100.1, we have the RD value over here 100.2. In this scenario, we can have two different customers with the same IP address. So this IP address which we will be receiving on the customer A will be 10.10.10. maybe 10, and then appended with 100:1. So we have the IP address available with appended with RD value. This is something known as VPN v4, which is 32-bit plus 64-bit. It is equivalent to 96-bit of the address. So we are creating the VRF. It means it is bit like if you know about the switching thing, that we are dividing the switch into the different broadcast domain using the VLANs. Similarly, here we can create different VRF for the sake that we can able to understand which customer belongs with which kind of VRF. So I was talking about the IWAN. In the IWAN, we are creating different VRF. One VRF with respect to the ISP known as front door VRF, and the second VRF with respect to the LAN towards the LAN, it is known as inside VRF. Now we are segregating the routing part with using the VRF fundamental or maybe the route domains. And we can use one of the maybe protocol when we are using overlay, like probably EIGRP. So here, if we are using IWAN, the very first thing which came into the picture is the transport independence. That the transport is not making the pain, is not the pain area for us when we are using it. So that is the very first thing. And how it is achievable? It is achievable again due to our DMVPN. So in the background or in the base, in the backend, the DMVPN was the terminology which was working end to end. And for the DMVPN, I hope you guys are aware that we can have hub and spoke topology. Okay, and it is perfectly fully mesh. In hub, we will be treating as the data center as the hub. Maybe all of the data centers are the hub. Rest of the sites we can treat them as the spokes. So since DMVPN is included over here, so security is also taken care by using the VTI policies, okay, or maybe by utilizing the IPsec headers, either it is ESP or maybe the transport mode. Then not only this, we are having the security. So I told you about the security. So security is there. Third, I will talk about overlay is there. Fourth, we have the direct internet access availability over there. Now let us suppose if we have the internet and the MPLS link, okay, we need to provide out the, let me just give you one example. I have the site A, I have the site B. For the site A, site B, I have the MPLS connection only. And somewhere, maybe there is a data center in the Singapore, okay, this site in the Mumbai, this site into the Delhi. If someone need to go to over the internet site, okay, over the internet, they need to go to the internet breakout, and from there they need to go outside. So that is a huge problem. Our traffic is moving from the complete one country to another country. So that part is also mitigated from here. The reason being, the sites which are going to the internet, they can go to the internet link directly. So we can play with the routing part over here. So that means it has the direct internet accessibility for maybe your your cloud services, for maybe the guests. So for that you can have this, and the security part is taken care with your Zscaler, maybe with your Cisco umbrella, bit like that. All of those parts are taken care. Then not only this, it also induced something named as intelligent path control. What is intelligent path control? Let us say this site has two links, the MPLS link and the internet link. Now, if we are having such kind of structure, we can be having the ECMP. ECMP means equally cost multipathing. Okay, you can go from either of the link or maybe for both of the links depending upon your load balancing mechanism. Or you can be having some kind of PBR, policy-based routing, like, okay, some traffic need to be go from the one link, some traffic need to be go from the second link, bit like that. But all of these things, what the static things, these are known as the static methods. Like you are defining once, and whatever you are defining, that is fixed. Now, whatever traffic will be moving, that will be moving bit like that. But somewhat, Cisco come up with the PFR, named as performance-based routing. Okay, so in the PFR, or if I will come to the SD-WAN, you will be able to understand that it is known as AAR. So what does this AAR means, or what does this PFR means? This is very intelligently check out your all of the tunnels which is created from maybe MPLS, maybe which is created from the internet, and they will check, okay, what is the packet loss? Maybe the packet loss on the MPLS and over the internet, it is measuring. Okay, it will measure maybe in some duration. Let us say the packet loss on the MPLS is 5%. Over the internet, it is 1%. Then it will check that, okay, what is delay? Let us suppose, again, the delay is more on the MPLS. Let us say 10%. Sorry, not percent. It would be maybe in the millisecond. Let me say 100 millisecond. And here it is 50 millisecond. Again, if you will talk about the jitter, what about the jitter? Again, jitter, let us say it has 50 millisecond, and it is also the 50 millisecond. Now, it will say that, okay, if I will check my tunnel traffic, this particular tunnel is not good. I should be moving my traffic from the internet. It is nothing done by you, but it will be done with the help of some measurements. And it was introduced, all of these things were introduced in your WAN 2.0 also. That is nothing but your IWAN. Okay, so it collects the values, measure it, and take the decision by its own. Nothing need to be changed manually. Intervention is not required. Automatically it will be done automatically. Okay, so it is not a new technology that Sd-Wan is showing you that, okay, we are using AAR, application aware routing. It is nothing new. Okay, these are, all of these things are the old technologies. But when I am talking about Sd-Wan performed one thing, that is it simplified it very very much thing. So earlier there was so much of the complexity with respect to the configuration part, but in case of Sd-Wan, when we need to configure the AAR, okay, it is very simple. You should be only aware about the concept. Rest of the things will be working automatically by its own. We need not to make any changes by our own. So I will say that if we have a couple of the sites, like 5 sites, 10 sites, 15 sites, deploying the Sd-Wan is not a very good solution over there. Okay. In spite of that, we should be sticking up to the IWAN. Probably IWAN is providing us all of the things which our Sd-Wan can do. But when there is a lot of other sites which are involving, maybe we have 2.5K of the sites, we have more than that, then Sd-Wan will come into the picture. So the third part which I need to talk about over here is Sd-Wan. Okay, so what is Sd-Wan? Sd-Wan, why Sd-Wan is required? That I told you, that if we have the number of the sites are more than, why not IWAN, or why Sd-Wan? So I will say the one criteria, that is number of sites. Now, when I am coming to the Sd-Wan, Sd-Wan is clubbing all of the features which I told you before. The features I talked about, that, okay, we could have the transport independence. Sd-Wan is also providing the transport independence, but obvious. Give me a minute. What happened? Let me look at this. Sd-Wan. So it is providing us the transport independence. So what kind of tunnel it will get created? What kind of protocol it is using? That we will check maybe later on in our Sd-Wan architecture. But currently, I am telling the very first thing when you are using Sd-Wan is the transport independence, which is into the hype. Second thing, if you will talk about the monitoring features, it is deploying the lot of the monitoring feature, some paid services known as vAnalytics, which we will be, again, I would be showing you later on. But vAnalytics is a very powerful tool. Third, if you need to, maybe if you have 3,000 of the sites, okay, or maybe the devices, or 3,000 sites, 2 devices per site, 6,000 of the devices, or more than that, 10,000 of the devices. Can you think what would be the operational cost, or what would be the OPEX? Okay, the OpEx for managing such a huge thing will be very, very high. If you need to do maybe some kind of upgrades, if you need to do some kind of version control configurations, then it's not a good way that you are going to the IWAN, you are sticking with the IWAN, or you are manually doing all of these things. IWAN is not a good idea there. SD-WAN is coming to the picture for those kind of huge technologies, okay, huge techniques when we need to use. So using this, like we have the Flex VPN, which is combining our all of the things in the newer way, bit like that. SD-WAN is nothing but it is controlling all of those things in the newer way and in the simpler way. Like it is also using VRF. It is also using VRF. It is also using overlay. It is also using the security part. As I told you, it is also using the PFR, which is known as AAR in case of our SD-WAN. But it is making so much simplify for us. And when it comes for the operational cost, it is one-time cost when we are purchasing this kind of license from the Cisco. But later on, if we need to check out the operational cost, it will be highly reduced. Secondly, you can do these things maybe by yourself also using the automation. Okay, if you are very good in automation, maybe you have the team for the automation, you can do that. But again, you need a dedicated team for such kind of huge automation to be done into your network. If you need to introduce some new features, like I was saying about the monitoring, like I was saying about the cloud security, or maybe different features, then you should be having the very highly skilled automation team, and the cost will be again gonna high. Okay, if people are leaving the organization, new people, you need to hire them again. All of these things will be happening. But where Cisco Viptela will say that, okay, we are doing everything for you. We are doing that job. We are automating with respect to the customer. New feature, we are putting it. You just tell us and we will get it done. That is something known as intent-based networking, IBN. What is IBN is? So in SD-WAN, there is something which is known as IBN, intent-based routing. It means whatever you think, if you are thinking that, okay, my topology should be a bit like that, whatever plan you have, whatever design you have, if you have the design, then you just push it to something known as controllers. In SD-WAN, we have something known as controllers, and you put it into the controller in turn will say that, okay, that policy need to be deployed, and how the routing traffic need to be moved, it will be shown. Let me give you an example. Let us say we have a router 1, we have router 2, we have a router 3. Currently, all of them are able to communicate with each other. As per my new design, I am saying that the communication between R2 and R3 should not be through. When R2 need to go to the R3, it should be going from R1. If I need to do this kind of job into my typical environment, or WAN 1.0, I need to play with the routing stuff. I need to use the route map. I need to use the ACL or a lot of other things. But when SD-WAN is coming into the picture, I need not to do anything. I just need to create some kind of templates, and I need to push that policies, and those policies will take care of all of these things in regards that whatever routing I need to do. And these controllers, again, before SD-WAN Viptela, Cisco was also coming up with these kind of controllers in the IWAN, and Cisco was also introducing their own SD-WAN, but they were using the controller like Epic EM, again the same controller which we are using for the ACI. But for the different reason, one of the reason that it was the hardware based and very costly, very expensive. So Viptela came into the picture. Viptela was an different organization. Viptela was altogether a different organization, which is renowned for known for its solution for SD-WAN. And in 2017, Cisco acquired it. If I'm not wrong, $610 million USD. It was a deal. Okay, And not only Viptela is the running solution in the SD-WAN. There are a lot of the vendors. Like we have the very popular Velo Cloud. We have Silver Peak acquired by HP, if I am not wrong. We have Palo Alto. We have lot of others. Versa. Okay. We have lot of other top working vendors in case of SD-WAN. It is Fortinet also. So maybe more than 150, about 150 companies which are providing their SD-WAN solution. Even every company, every re-owned company is providing their own SD-WAN solution. So why I am telling that SD-WAN come into the picture? SD-WAN come into the picture because it is providing a lot of things. Like I told you, monitoring part, I told you OpEx cost, I told you about security, I talked to you about transport independence. So all of these benefits were introduced by the Viptela. Okay. Now, what it does? Let us understand what it does. If we just talk about a multi-chassis, maybe switch. So in case if we have the multi-chassis switch and you need to send the traffic from one line card to the another line card. So traffic is coming in from here and going out from here. What would be your control plane? Your control plane would be, if it is SU based, the supervisor engines would be your control planes. So that is your control plane. But your exact data plane is what? Your data plane is from this particular of the line cards, from where this traffic is coming in, from where the traffic is going out. It means in case of our previous topology or in case of our previous networks, the control plane and the data plane, the control plane and the data plane was clubbed each other. So if we have couple of the switches, maybe I have 10 switches or maybe 5 switches in a device, okay, sorry, in a site, on a site, and I am running OSPF over here. It means I need to do the configuration on each and individual place individually, manually, and every device is taking care of their control plane and every device is taking care of their data plane respectively. But when SD-WAN come into the picture, okay, the very first thing, what happened technically now I am talking about, it decoupled the data and control planes. So both of the data plane and the control plane were decoupled. What does that mean? That means now it introduced something known as controllers. As I was talking before also, it introduced something known as controllers. So the data plane is now having a different layer, data plane. The control plane layer is some, okay. The control plane layer is something very different. Not only that, on the top of that, we have two more layers. One is the management layer, and one is the orchestration plane. So it decoupled your data plane and the control plane so that your traffic now, when you need to manipulate lot of your traffic part, you can push the policy only onto your control plane, and your control plane will push it to the data. So these are a bit like your plug and play devices or zero touch provisioning. We used to know about that terms also. So one thing is it build an overlay over the top of your internet or maybe MPLS or maybe LTE or maybe 5G, whatever. Transport independence is there. Second thing, decouple the things. Third thing, security out the routing scale. So providing a lot of security things over here. So SD-WAN provides a security in the form of encryption, device authentication, and when the founders were applied their expertise solution in the routing protocol, they just checked with respect to the security end to end. So Viptela router can connect maybe, all entities are automatically between the different device through the VPN connections. So overlay is introduced, security is introduced, and then we are saying that control plane is now centralized. And since it is centralized, we can push the policy maybe approximately on the thousand of the site in one go. What we need to do? We need to enforce the policy for the specific location, doesn't matter. Go to the centralized controller, push there. If you need to push the or induce the policy for maybe enforce the policy for thousands of the devices, we can push that without any issue. We will go to the control plane. Okay, we will go to the kind of controller and we can do each and everything over there. So let me show you this with a particular diagram. Maybe you guys will be able to more understand about that. So we were talking about the WAN 1 on O and 1 on 2 over here. Let me just go to the SD-WAN architecture. By the way, so far, anyone has any questions? You can ask. No? Perfectly fine. Now, I will be talking about a couple of the controllers. So you can see, this is my data plane. And data plane, in my data plane, the devices which are coming are the WAN edges. So these are the WAN edges. Whatever WAN edge I have, maybe if I will check my older diagram, here the WAN edges are this, like this is my WAN edge. Where is that? Okay. This is my one of the WAN edge. This is my one of the WAN edge. It can be Viptela device. It can be CSR. So if it is Viptela device, it will be known as VH. If it is a Cisco device, okay, like CSR, it will be known as CH. Bit like that, there can be WAN edge devices. So when we have the WAN edge devices, our all of the data plane will be taken care by these devices. Either these can be into the cloud, data center, colo, campus, branch offices, wherever. Then we are having MPLS, internet 4G, whatever kind of network, or maybe we can say the underlay network, whatever we have, we can connect with our controllers. So these controllers are known as vSmart. vSmart is the controller which is taking care for your SD-WAN control plane architecture. So any kind of policy when we need to push, we will be pushing it to the vSmart, and vSmart will be pushing it to the WAN edge devices. And then WAN edge devices will be working as per the instruction provided by your vSmart. So you can able to see like that all of these things are like same. So we can also say that now whole of these things is bit like working as the single fabric. Like earlier, we have the multi-chassis system. Here, the backplane is nothing, but the backplane is our internet MPLS 4G connection, bit like that. So that is how our MPLS will be, MPLS is, getting out, and our SD-WAN is coming into the picture. So one thing I talked about data plane. Data plane means the end devices, the WAN edge devices, either the V edge, either the C edge, that will be working, okay, which is passing the data. Then I am talking about the control plane. Control plane is nothing but the vSmart controllers, which are taking care of your routing part. Now, going forward, if you will check the management plane, in the management plane, we have another controller known as vManage. So vManage is something from where we will be managing each and everything. Okay, and this is the purely GUI part where we will be working more and more onto the vManage, and from here we will be pushing out any kind of templates, any kind of policies, either it is routing policies or maybe the local to the site or maybe the centralized policy, doesn't matter. Whatever policy I need to run upon, we will be using the vManage. So these are the controllers, vManage, vSmart. These are the two controllers which will be come into the part very much. Then the third controller, which is not showing over here, maybe I will be showing into the next diagram. That is your that is for your orchestration plane. Let us see that in the maybe next diagram. Okay. So we have total 4. One is the data plane. In the data plane, we will be having the vBone. Sorry, we will be having the VH or maybe CH. Orchestration plane, in the orchestration plane, we will be having the vSmart. In the control plane, we have the vSmart. Then management plane, we have the vManage. Then the orchestration plane is something bit like your glue. So whenever all of these components will come up, how they come to know that which is my control plane, which is my vSmart, which is my vManage. So very first, whenever some device will come up, it will talk with its vBond because it will be having the IP of the vBond. And vBond in turns will let it know that which is your vManage, which is your vSmart. And by doing so, your whole of the fabric will come up. So that is how your SD-WAN will come up in, in your lab topology. Also, you can able to see. Let me show you about our lab also. Okay, so where is our lab? Let me bring the lab for you guys. So this is the lab topology on which we will work. Here you can see we have all of the controllers available. Okay, like either it is vSmart, which is our control plane, vBond, orchestration plane, vManager for the for your management plane, and either you have all of the VH devices for your data plane. Here we have the root CA server also. We have two of the connection ISPs, one for the MPLS, one for the internet. We have all sort of sites which is connected with the internet only, which is connected with maybe MPLS and internet both, or maybe there is dual connectivity with your dual WAN devices. Okay, so we have a couple of these things, and we need to see that all of the communication is going through. Okay, and we are running maybe all sort of routing protocol also. We need to check that okay, how our devices will be device traffic will be moving from one place to another using SD-WAN, using OMP, using BFD tunnels, using IPsec tunnels. So all of those things we will be gonna check. Now let me take the console. And let me just log in over the vManage. By the way, you guys will also get this kind of topology, okay, where you will be working from the scratch so that you can run by your own way and you can learn the things from the very basic steps. Okay. So since all of the devices are not up, I hope this device is down, this device is down. So a couple of the devices are showing over here as the down. Some of the devices are showing over here up. That is perfectly fine. It depends upon your network to network. But you can see this is your Cisco vManage. This is the GUI part. From here you can see lot of things. What about the control plane down, control plane up? Not only these things. Whatever thing what I was talking about AAR. You can see over here that okay, it is checking the latency, it is checking the average loss, it is checking the jitter, bit like that. Okay. And from here, maybe you can check your network, whatever the things are into your network is. If you wanted to take the control, maybe you can take the control from here also. Okay. If you wanted to maybe run some kind of commands, you can go over here and maybe run some commands. What about maybe OMP peer? If I wanted to check, I will be issuing the command. I need not to go to the CLI. Even if I need to go to the CLI, I can check the CLI from here. Again, lot of things are here to understand, lot of things are here to do, or to work on. Like if I need to take the console of the CLI, I need not to go to the CLI individually. I can go from here and I can take the CLI part of any of the device from here also, like show MP peer or whatever I want to use. I can use those commands here as well. So this is the high overview of the SD-WAN. Again, about architecture or about every type, everything we will be going to talk in the classes. Any doubts so far to anyone? Okay, we will be sticking up with all of the syllabus, which is as per your CCI enterprise, maybe more than that. We will be like taking these classes in the weekends. Weekends are based on India, that is Saturday and Sunday. Class timing probably would be from 11 a.m. to 1 p.m. 2 hours class. Okay, you can check the syllabus. If you wanted to check the syllabus, you can go to our website and you can check from here there. So if I will be showing our website, netminion.net. You can just go, you can check a lot of other courses also. Then whatever we are teaching, everything will be get recorded and you will get the recording, which you can access through the NetMinion app or maybe through the web portal. And you will be having the lab access, which is 24/7 up. If anybody has any other doubt, maybe please ask. Otherwise, I hope we are good to wrap up. No? Okay, I would say thank you for joining us. And if you have anything, maybe you can just talk with us through the website also. You can ping from here, you can ping from here, or you can reach to Joya, you can reach to us whenever you feel like.
One question, what will the duration of the course?
It would be going around, if I'm not wrong, 16 to 18 hours. Exclusion it?
Yeah, thanks.
Sure. So if nothing is there, then I would like to say thank you again for joining in.